Okay. Good morning, everybody, and welcome to our pre-calculus class. Today, what we're going to do is we're going to continue on chapter 3, and we are now on lesson number 2, trigonometric ratios for special angles. So, when we talk about trigonometric ratios from last lesson, we said that we were looking at trigonometric ratios at the different angles, but these ones are special angles, and what makes angles so special? I'll talk about those things. So it says here, determine the exact value of trigonometric ratio means that you determine the ratios without using a calculator. We can determine the values of 6 trigonometric ratios by using our knowledge of the right angle trigonometry ratios, the Pythagorean theorem, isosceles triangles, and 30, 60, 90-degree angles, triangles. Now, before we get into that one, I just want to, this is one way of, we can look at it in terms of figuring these out. We are working on a unit circle. Let me grab my marker in here. So in terms of a unit circle. Okay. So before jumping on this, I just want to explain some stuff in here. Let's say we have an isosceles right triangle. What does an isosceles right triangle look like? So it means that it's a right angle triangle in here, and isosceles means that this side and this side are equal to each other. And because we're talking about unit circle, that means this line here is going to be 1 unit. So what we're trying to figure out is what is this length and what is this length. Okay. I will tie it in with the notes that we have in our booklet. So what we can do is we can use our knowledge of the Pythagorean theorem. We said that in a Pythagorean theorem, x squared plus y squared equals to the hypotenuse squared. I'll just use this a squared plus b squared equals to c squared. So this one will be, well, we don't know that value, x. Now, because this side and this side are the same, I'm just going to call them both x squared. And then this one is going to be equal to 1 squared. Isosceles. I didn't write it down in here. Isosceles, right triangle. And that's what we have right here. Isosceles right triangle. So this side we don't know, and this side we don't know, but we know that these two sides are equal, the legs and then the hypotenuse is 1. Well, because x squared plus x squared, that's going to give us 2x squared equals to 1 squared is just 1. Divide both sides by 2. The 2's cancel. We have x squared is equals to 1 over 2. The next thing that we have to do is take the square root on each side of the equation. So the square root. So x, with that, I'm going to have the square root of 1, which is 1, and then the square root of 2, which is the square root of 2. We can write it like this, but sometimes in other texts, this is perfectly fine. But other texts, what they do is they rationalize the denominator. So you might see it in other texts and other parts of the book, might be from our book as well. They would rationalize the denominator, meaning that they don't want the radical in the denominator. So how do we do that? So this is what we started off with. What we're going to do is we're going to multiply by root 2 over root of 2 on numerator and denominator. So basically, we're multiplying by 1 in the form of root 2 over root of 2. And in that particular case, we have 1 times root of 2 is root of 2. And then root of 2 times root of 2, that's going to give us root of 4, which is 2. So x, okay, I'm just going to write it down here. Rationalize the denominator. Okay, so root 2 over 2. In this particular case here is 1 over root of 2 or root 2 over 2. Now, because the x, this side and this side are exactly the same thing, so that means this is also 1 over root of 2, which is also root 2 over 2. Okay? Now, this looks like has nothing to do with our picture in here. Actually, it is. Because if we have this triangle right here, because it's an isosceles, this is 90 degrees, this has to be 45 degrees, and this has to be 45 degrees. That the sum of all the angles in the triangle is 180. Let's take this triangle, physically take this triangle, and then put it right there. So that means this is the isosceles right triangle. Over here, this length on the x is going to be 1 over root of 2, which is the same thing as root 2 over 2 if we rationalize the denominator. This is the x, and then this is the y. The y would be 1 over root of 2, which is the same thing as root 2 over 2. If this length is 2, root 2 over 2, and then this height there, or along the y, is root 2 over 2, then the point theta, in this particular case, is, I'll just go root 2 over 2, 2 over 2. So it's rationalized denominator. So this one will give us the x, and then this one will give us the y. Now okay, sorry, you can't see that one. Now, what does it have to do with our trigonometric ratios? The x value, we said earlier in terms of our unit circle, x is the same thing as cos of the theta. Cos, so that means cos of the theta, 45 degrees, is root 2 over 2. And then the y, that's the sine theta, how far up it is on the Cartesian plane here to get to that particular point. That's the sine theta is equals to root 2 over 2. Okay, so that's that part. Okay, I'm actually going to put in here cos of 45. Cos of 45. Fix that one. Because I know the theta is 45 degrees. Okay. So cos at this particular angle is that. Now 45 degree angle, that's our reference angle in here. So this is 45, This is a reference angle at 45. This is a reference angle at 45. And this is a reference angle at 45. So these are 45, 45, 45. If we go all the way down from this initial arm to go to that side, now this becomes, this is a reference angle of 45 degrees. How big is this angle here? Then this one would be 180 minus 45. 180 minus 45. So if we go this way, this is going to be x. Okay, so x here. X is going to be on the left side, so that we can indicate that it's to the left by saying it's negative root 2 over 2. Okay, and then the y, it's still a positive y value. It's going to be y equals to positive root 2 over 2. So the point there, the point xy, is at negative root 2 over 2, comma, positive root 2 over 2. Well, what does this really mean in terms of our angle? Well, that angle, the x here is the cosine of from angle here to there. That's going to be 180 minus 45 degrees, so that's 135 degrees. And then the y would be the sine of 135 degrees. So when we put in the cos of 135 on our calculator, we're going to end up with a negative value. Cos of 135 degrees, we're going to get in a negative 70.707. Well, this value is actually, if we type this in, this is the exact value, and this is the approximate value of negative 2 over 2. And let's go all the way around in here. You'll probably see that there's a reflection. In this particular case, what happens is that if this is again 45 degrees, okay, I'm just going to keep going with the red. This is negative on the x and then negative on the y. So y is equals to negative root 2 over 2. So this coordinate over here, that's our xy coordinate, would be negative root 2 over 2, positive root 2, negative root 2 over 2 as well. Negative, negative. And what does the x and y mean? So this is going to be the cosine. The x is a cos of an angle. So cos of what angle are we talking about? So from this angle, from here, initial arm to this terminal arm at 180 plus the 45 degrees. This is our theta r. That's going to be 180 plus 45. That's going to give us 225 degrees. And then the y would be the sine of 225 degrees. So if the question says, what is the cosine of 225 degrees? What's a cosine of 225 degrees? Well, that's the negative root 2 over 2. And if the question says, what is the sine of 225 degrees? That's going to be negative root 2 over 2. Okay, now let's go to the next one over here. This particular point on the unit circle, positive root 2 over 2, and then the y would be negative root 2 over 2. negative root 2 over 2. So the point there, x comma y is positive root 2 over 2, and then the y would be negative root 2 over 2. And again, this x, that's the cos of the angle. Well, what angle are we talking about in standard precision? That's from 0. Okay, so this is the initial arm going all the way around to this terminal arm. And how much did we turn that way? All the way down here. So that's going to be 360 minus 45. 360 minus 45, so that's 315 degrees. So if we type in, okay, so cos of 315 degrees, they're really asking for the x coordinate in a unit circle, positive root 2 over 2. And then the y would be the sine of 315 degrees, which is negative 2 root of 2. Okay, so take a look at these questions. This is a special angle of 45-degree angle of reference angle. Okay, so reference angle of 45 degrees. We talked about the cast. We talked about cast before, and we said this is follow the cast idea. So here, remember in cast, C A S T. This is a really nice acronym to kind of help us out with figuring out our solution, because later on we're going to talk about solving a trig equations. So over here in this, let's start off with this one here. In quadrant 1, all trig ratios are positive. So that sine, cosine, tangent are all positive. And then when we look at this one, yeah, they are positive. Cos of 45 is positive. Sine of 45 is positive. And then tangent is going to be positive because tangent is sine divided by cos, or y divided by x. Take a look at this one here. In quadrant 2, only the sine is positive. Only sine is positive. Sine of 135 is a positive. Cosine is negative, and tangent will be negative as well. In quadrant 3, only the tangent is positive. Well, why is it tangent positive in here? Cos and sine are both negative in quadrant 3, but remember when we talk about tangent, tangent is y divided by x, opposite over the adjacent. If we divide these two, we're going to end up with a positive value. And then lastly, in quadrant number 4, only cosine is positive. Cosine is the only thing that's positive, and it's true here. Cos is positive, sine is going to be negative. And then because only cosine is positive, tangent will be negative in this case, because tangent is y divided by x. Y divided by x, which is going to give us a negative value. -1 to be exact. Okay, so that's that piece. So these are the exact values. Now we're going to move on to the next page. This one, exact values with reference angle of 30 degrees. I'm going to be able to do the 30 degrees and 60 degrees together. Okay, because they're very, very related to each other. I'm just going to grab a piece of paper in here. I'm going to show us how that number came to be. A unit circle. Now in this case, we're going to end up with, I'm going to do special angles. $60 and 30 degrees combined. Okay, so how do we figure out the trig exact values for the trig ratios for these two angles, 60 and 30? Well, what I'm going to do is I'm going to start off with equilateral triangle. Equilateral triangle. So what does an equilateral triangle? Equilateral triangle means a triangle with three equal sides. Okay, so what I'm going to do is I'm going to create a triangle with three equal sides here. Try to make it bigger. Okay, so three equal sides right there. Well, what's the length of each side? What I'm going to do is I'm going to stick to the unit circle. That means, having said that, that means each side is going to be 1, 1, 1, 1. All three equal sides. Another special thing about the equilateral triangle, besides the fact that they have three equal sides, it is that they also have three equal angles. So three equal angles there would be 60 degrees, 60 degrees here, 60 degrees there. Okay, so that's a great start. 60, 60, and 60. And that doesn't, that's a property of a triangle, that the sum of all the angles in a triangle adds up to 180 degrees. So what does that mean? What I could do is I could cut this in half. So cut this in half. So if we cut this in half, then I'm going to be left with this triangle. I'm going to be left with a 60 degree. And now, because I cut it in half, now this is 30 degrees. And you're probably seeing where the 60 and 30 degrees are coming from. This is still 1. Now, because I cut this part in half, now this one would be a half. Okay, so the x is 1/2 in here. X is 1/2. Now, what about the y? What about the y? What about this part here? Well, we can use Pythagorean theorem. To calculate the y. So it's going to be 1/2 squared plus y squared equals to the hypotenuse, which is 1. So that's going to give me 1/4 plus y squared equals to 1. So bring the 1/4 to the other side, 1 y squared. In this particular case, 1 minus 1/4. We have to have the same denominator here. So 4/4 minus 1/4. Oops, y squared. So y squared is equals to 3/4. And then finally, we have to take the square root on each side. So that becomes √3/2. So √3/2. root of 3 over 2. Okay, so let's physically take this picture, and put it right. I'm actually going to go to page 12. Okay, so let's go to page 12 because that's a 60 degrees here. So page 12 first. So I'm taking this 60-degree triangle that we created over here and then putting it right there. What does that mean? This is a 60 degrees. So the reference angle is 60 degrees here. How far is this part in here? So this is going to be 1/2. And then how far up is this? It's going to be root 3 over 2. And that's the y. Okay. So what's the point over there? So what's the coordinate of that point there? So x comma y is going to give us positive 1/2 comma root 3 over 2. Okay, so let's remind ourselves, what does the x represent again? X is the cos. This one would be the cos of 60 degrees. Cos of 60 degrees is 1/2. And then the sine of 60 degrees is root 3 over 2. So try that on your calculator and see. Cos of 60 degrees is going to give us 0.5 because it's 1/2. And then sine of 60 degrees, it's going to give us a whole bunch of decimal, 0.866. Well, that's actually the value of root 3 over 2. Now, let's go to this side. This is going to be a reference angle of 60 degrees. The x value is negative, so it's going to be negative 1/2. But the y value is positive root 3 over 2. Okay, so what's the point over here? So the point would be negative 1/2 comma root 3 over 2. Well, what does that mean? That means, what angle is this? Cos of what angle? From here to this terminal arm, that's going to be 180 minus a 60. So that's going to be 120. Okay, so cos of 120 is, so cos of 120 is going to be negative 1/2. And then this number is going to be sine of 120 degrees is going to be root 3 over 2. Let's go to the next one, quadrant number 3. Again, reference angle of 60 degrees here. X is negative 1/2. Y would also be negative root 3 over 2. So what's the point onto our unit circle? It's going to give us negative 1/2 comma negative root 3 over 2. And what does this angle in standard position? So if we go from here, initial arm, all the way to this arm, which is a terminal arm, that's going to give us 180 plus 60. 180 plus 60, so that's going to be 240 degrees. So cos of 240 degrees is negative 1/2, and sine of 240 degrees, that's going to be negative 3 over 2. Okay. Let's take a look at quadrant number 4. In quadrant number 4, x is positive, y is negative. So it's going to be negative root 3 over 2. And that's going to be 1/2, comma, negative root 3 over 2. So this one here is our x, and then this is our y. And x and y, what does the x represent? That's the cos of the angle. Well, what's the angle? Angle is from initial arm all the way to the terminal arm over here. So how big is that angle? If this is 60 degrees as our reference angle, then that's going to be 360 minus 60. That's cos of 300 degrees. And that's sine 300 degrees. Okay. So these ones are the special angles with reference angle of 60 degrees. So reference angle of 60 on each quadrant, right? The reference angle means an angle between initial arm, angle between the x-axis and then the terminal arm. What else? So the angles that has a reference angle of 60 degrees are 60, 60, 120, 240, and 300. Okay, so all of these are also from lesson number 1. So make sure that you keep up with the lesson 1 if this is something that you're not quite sure of yet. Now I'm going to go back to page 11. So this is what we had earlier. Okay, this is what we had earlier. Instead of having 60 degrees in here, I'm actually going to be using the 30 degrees. Okay, so I'm going to switch it around. So if the angle looks like this, I'm going to do it in a separate sheet of paper. If I switch it around, I would have 30 degrees. Well, that doesn't look like 30 degrees. Pretty close to 30 degrees. If this is 30 degrees, then that means, and then this is hypotenuse is 1, then this is going to be the 1/2. Right across this 30 degrees is the 1/2, and adjacent to the 30 degrees would be root 3 over 2. Okay, so physically take this one and put it right there. So what does that look like? So x is going to be a positive root 3 over 2. And then the y is 1/2. You know, like if you actually look at it this way, so you create a unit circle and then kind of approximate with 30 degrees is, and then draw your vertical line for y and then horizontal line for x, you're actually gonna see that this is halfway of the whole thing. So if this is 1, 1/2 would be like, this is going to be about a half, or exactly a half of 1. So in that case, the x is root 3 over 2. And then the y is positive 1/2. Okay, so what does that mean? So root 3 over 2, that's the cosine of 30 degrees. And then the 1/2, that's the sine of 30 degrees. 30 degrees. Okay, now let's go on to quadrant number 2. So all of these have reference angle of 30 degrees. Going to the left side, that's going to be a negative root 3 over 2, and then positive 1/2. So this particular point on the unit circle is going to be negative root 3 over 2, comma 1/2. And well, what does that mean? This one is going to be cos of an angle, and then this is going to be a sine of an angle. Well, what angle is that? What angle is that? So from here to there, that's going to give us 150 degrees. Because if I go all the way on there, it's 180, but take away the 30, so that's 150 degrees. Okay. Now let's go to the next one in quadrant number 3. X is negative, Y is also negative. So this is going to be negative 1/2. So the point there is negative root 3 over 2, comma negative 1/2. Both X and Y's are negative. Okay, so we know that this is going to be cos of an angle, and we know that this is a sine of an angle. Well, what is that angle? How big is this angle in standard position if I go from here all the way down there? So from here to here is 180 plus 30 more. So that's going to be 210 degrees. 210 degrees. Okay. And then finally, last but not the least, if we go all the way down to quadrant number 4, that's going to give us positive x and negative y. So this is going to be a negative 1/2. So that becomes 3 over 2, comma negative 1/2. Okay, cosine is positive because x is in the positive and then y is in the negative. So this is going to be cosine of an angle, and then the negative 1/2 is a sine of an angle. So what angle is this? What angle is this? So if we go from here all the way around, how big is that angle? So from here to there, that's going to be, if we go all the way around, that's going to be 360, but we didn't go all the way around. There's 30 degrees back that we had to go. So it's going to be 330 degrees. It's 330 degrees. Okay. So these angles, 30 degrees, 150, 210, and 330, are all of the angles that has a reference angle of 30 degrees, and then we were able to find their x and y, cos and sine of those particular angles, and these are exact values. Okay, so right now they're separate. So we did 45, we did 60, and we did 30. Now we're going to get into the quadrantal angles. Quadrantal angles, meaning right on the quadrants. So here, if this is the particular point, our x and y, this point is going to be at 1, 0, because x is 1, but we don't go up at all, so it's 0. What angle is this? So this is going to be the cosine of 0 degrees. And then this is the sine of 0 degrees. So if you actually type it in onto our calculator, let me find my calculator here. Okay. That's why when we say cosine of 0 degrees is 1. It's really telling us how far along the x is that point in a unit circle. And if we go sine of 0 degrees, so we're going to get a 0. That means how far up in the unit circle did we go if we are at 0 degrees? Well, we didn't really go up. That's why it's 0. So here, what would this be? Our xy point, this is going to be 0, comma 1. 0, comma 1. Well, from here to here, what is that angle? This is going to be the cos of 90 degrees, sine of 90 degrees. Cos of 90 is 0. Sine of 90 is positive 1. So if we type that into a calculator, cos of 90, we're going to get a 0. And if we type in sine of 90 degrees, we're going to end up with 1. Okay. Now let's get into this one right here. We know that this is going to be -1, 0. -1, 0. So that's the x and y coordinate on a unit circle, but -1 is a cos of 180 degrees. And then the y is the sine of 180 degrees. Okay, and all the way around here in this quadrantal angles. The coordinate point is 0, -1. 0, -1. And this is our x and y coordinate. And then what does the x represent? That's the cos of an angle. Well, what is that angle? 270 degrees. And then the -1 is our y. Well, what does the y represent? That's the sine of the angle, which is 270 degrees. Okay, well, let's try it. Let's try cosine of 270. So cosine of 270 degrees equals 0. Let's go sine of 270 degrees. It's -1. So if we figure this out, okay, if we know what the angle is, we can figure out the sine of the angle. It's -1. And if we have the -1, we could actually figure out the angle. Okay, so that's a really, really good exercise. Let's get into the example now. Yeah, we have a little bit of time for it. This is not going to take long. So determine the exact values of the 6 trigonometric ratios for each angle. Now we're going to take a look at the 6 trigonometric ratio. That's going to be sine, cosine, tangent, secant, cosecant, and cotangent ratios. Well, let's visualize this. Where is 120 degrees? 120 degrees is going to be, this is going to be 0, this is going to be 90. 120 would be somewhere right here. Now, because it's 120 degrees there, we could figure out the reference angle. So the reference angle there is going to be 60 degrees. So reference angle, 60 degrees. Now, looking at this one in here, imagine our unit circle there. Okay, so 60 degrees. Oh, this is about a half right here. So this is a half. And how far about is that? That's going to be root 3 over 2. So it's going to be cosine of 120 degrees is going to be 1/2. Sine of 120 degrees, that's going to be a positive root 3 over 2. Tangent, tan of 120 degrees. Tan of 120, tan is opposite over opposite over adjacent. So when you look at this, tangent is really the again, back up. Tangent is really the sine over cos. Tangent is really the sine theta, sine of 120 over cos of 120. Cos of 120. So what's the sine of 120? It's 1/2. What's the divided by? Nope. I'm always getting ahead of myself. What's the sine of 120? It's root 3 over 2. What's the cosine of 120? It's 1/2. So if you take root 3 divided by 2 divided by 1/2, that's a complex fraction, so the 2 cancels. It's going to be root 3. Root 3 or root 3 over 1. Now, what about the other ones? Well, the other ones are reciprocal of these 3 trigonometric ratios. So secant of 120. Secant is a reciprocal of cosine, which is 2 over 1. Cosecant of 120 degrees, that's a reciprocal of the sine, so that's going to be 2 over root of 3. And then the cotangent of 120 degrees is a reciprocal of tangent, which is 1 over root of 3. Okay, because this is root 3 over 1, so it's going to be 1 over root of 3. Okay, so that's a good question. From there we can figure out the whole solution. Okay, I just want to show you something in here for a second. Let's type in tan of 120 degrees on our calculator. Tan of 120 degrees. Oh, there's one thing that I forgot. I forgot here because it's a negative. A cos is negative here. This is positive. Then this is going to be negative. And then this is going to be negative. Secant is reciprocal of the cos, so it's also be negative, and this is going to be positive. So that's what I forgot to do. So tangent of 120 degrees, let's try that again. Tangent of 120 degrees, I ended up getting a negative 1.73. And if I type that in, negative root of 3 is actually negative 1.73. Okay, so I should put negative in here, negative 1/2. Okay, so let's go ahead to this one in here. I feel like I'm always running out of room, so I'm gonna just do example number 1B. it's going to be 450 degrees. Okay, so we're trying to figure out the 6 trig ratios for that. Okay, well, where is 450 degrees? Where is 450 degrees? Let's see here. This is my initial arm. And if I go all the way around, that's going to give me 360. But then I have to do a bit more to get to 450. So we have to go all the way around. And then how much more do I need to go? 450 minus 360. That's I need to go 90 degrees more. 90 degrees some more. Okay, so what does that mean? Oops, too much paper in here. We can do the sine, cosine, and tangent. So we're landing. This is my initial arm, and then I'm going all the way around, and then this is my terminal arm. Terminal arm. So where is this one here? The point there is 0, 1. So that means cos of 450 degrees is equal to 0, 0. And sine of 450 degrees, that's the y value, which is 1. Tangent of 450 degrees is the same thing as sine 450 over cos of 450. Okay, sine of 450 is 1 divided by cos of 450 is 0, and that's 1 divided by 0 is undefined. Undefined. Now let's go to secant of 450. Secant of 450 is the reciprocal of cosine. So it's going to be 1 over cos of 450. It's going to be 1, the reciprocal of 1 over 0, which is undefined. And then cosecant of 450 degrees is the reciprocal of sine, 1 over sine 450. It's 1 over sine of 450 is 1, so it's going to be 1. And then cotangent of 450 is the reciprocal of tangent, would be 1 over tangent 450. This is going to be really interesting because if the tangent of 450 is 1 divided by 0, the cotangent is the reciprocal of that, which is 0 over 1, which is 0. Okay. So this is just doing it on a separate sheet of paper for extra room in here, so I can show my work. Now let's take a look at letter C. Letter C. The theta is negative 225 degrees. Negative 225 degrees. Well, let's visualize where negative 225 degrees is. So the negative tells us we're going to be turning clockwise in here. So this is our initial arm, and then we're going to turn negative 225. So this is going to be 0, negative 90, negative 180, negative 270 here. Where is negative 225? So negative 225 would be from here, initial arm. We're rotating negative 180, and then I gotta do a little bit more this way, which is another 45 degrees. That's where it is. Okay, so we are landing in quadrant number 2. So drop our perpendicular line there. Our reference angle is 45 degrees. So because it's 45 degrees, that's going to be root 2 over 2, root 2 over 2. And again, this is negative, so it's going to be negative root 2 over 2. The y is positive root 2 over 2. Okay, so that's that point right there on my terminal arm. So the x is the cosine of negative 225 degrees is going to be negative root 2 over 2. Sine is the y. So sine of negative 225 degrees is positive root 2 over 2. Tangent of negative 225 degrees is sine of negative 225 divided by cos of negative 225. Okay, well, what does that equal to? Sine of negative 225 degrees, that's going to be root 2 over 2. Cosine of negative 225 degrees is a negative root 2 over 2. They're exactly the same fraction, so it's going to be negative. One is positive, one is negative, so it's negative 1. These are the 3 primary trigonometric ratio. Now we're going to do the reciprocal ratio, trig ratios. So secant of negative 225 degrees. Okay, what's secant again? It's the reciprocal of cosine. Reciprocal, so it means 1 over negative 225 degrees. Okay, now you're probably thinking, oh, do I really need to write this down? You don't have to. I just like to show that down. So that becomes, if you want to just take the reciprocal of these two, so it's going to be negative 2 over root of 2. And then cosecant of negative 225 degrees, it's going to be 1 over sine of negative 225 degrees. Okay, like I said, you could just take from here all the way down there because it's a reciprocal of sine. It's going to be positive 2 root of 2. And then finally, cotangent of negative 225. That's the reciprocal of tangent. Reciprocal of tangent, you can think of it as 1 over divided by tangent. Or reciprocal means cosine divided by sine. So it's negative root 2 over root of 2, root 2 over 2 is still negative 1. Okay. So sometimes when I even go through this particular part, like I want to try to make sense of it. I personally like to draw the pictures. I like to draw the angle so I can actually have a visual representation of what I'm trying to do. And then from there, does this make sense to me, right? Now let's take a look at the next one. Oh, this is a really big number. 690 degrees. Example Number 1D is 690 degrees. Okay, well, where is 690 degrees in our picture? Okay, because I want to try to make sense of this. Um, where is it? Let's see. Okay, 690 degrees. It's going to be a positive angle, so we're going to go counterclockwise. So this is 0, and if I turn it around, that's going to be 360 degrees. And then how many more do I need to go? So this is the strategy that I showed you at the beginning of lesson 1. I can go 690 degrees, divide by 360. So that's going to be 1, 360. It's going to give me 0, 3. That's going to be 330. So it's going to be going around one full revolution right there. But and then I have to turn 330 degrees more. So 330 would be like right there. So my terminal arm is right there, turning it around, and then one more, a bit more, 330 degree more turn. Okay, so what does that mean? It means that our reference angle in here is 30 degrees. Okay, so 30 degrees, if you get rid of all that's looping around there, you're going to end up with a 30-degree reference angle. So that means this is going to be at that point on a unit circle. If you do a unit circle right there, that's going to be root 3 over 2, comma, negative 1/2. Negative 1/2. So this is my x, and then this is my y. Now we are ready to figure out the trig ratio. So cos of 690 degrees. Okay, cos is the x coordinate. There's the x value, which is root 3 over 2. So positive x, negative y. Sine of 690 degrees is going to give us negative 1/2. And then the tangent of 690 degrees is going to be sine of 690, because it's opposite over adjacent, right? Opposite is the y, adjacent is the x. That's why it's y over x. Okay, so if my sine of 690 degrees is negative 1/2, and then the cosine of 690 degrees is root of 3/2. If you divide those, you're going to get negative 1 over root of 3. Okay, and then from there, we can do the reciprocal ratios. It's going to be secant of 690 degrees. That's going to be reciprocal of cos, so 2 over root of 3. Cosecant of 690 degrees is going to be the reciprocal of sine, which is negative 2 over 1. And then cotangent of 690 degrees is the reciprocal of the tangent, which is negative root 3 over 1. Okay, so a lot of background information from lesson 1, so make sure that you are, if you have questions with lesson 1, let me know. Oh, okay, I thought this is going to be a short one. We have example number 2 to do and example 3. sine of theta is equals to 1/2. Now, this is a backwards question because what we're trying to do now is what angle do I need to go to? What angle do I need for me to get a 1/2 for sine? Now, the domain of our, and theta has to be between 4 theta between 0 and 360 degrees. Okay, so that's a great thing. Okay, we don't have infinite solutions in here. So in the confined angles between 0 and 360 degrees, what angle would give me a sine of 1/2? Now, what does that mean? The sine of the angle is 1/2. That's sine is the y value is positive 1/2. Sine is talking about how far up is that particular point on a unit circle. So if you have a unit circle, where is the y value 1/2? Positive. Where is the sine positive? So we know that the sine is positive when it's in quadrant 1 and quadrant 2. So if we go here, we do, okay, looks, yeah, try to draw it out to make sense of this. What angle is it that I need to get a 1/2 for y? Well, that one would be 30 degrees. So 30 degrees here and 30 degrees there as a reference angle. So that means theta sine theta is equals to 1/2. So theta is equals to 30 degrees. That's in quadrant 1. And in quadrant 2 is 150 degrees. So we have actually two solutions in here. Two solutions. S2P. Cosine of theta is equals to negative root 3 over 2. So the cos represents the x coordinate or value, right? So the cos is the x coordinate, and we have to ask ourselves, well, where is cosine of theta negative? Well, where is cosine negative? Well, it's negative in quadrants. It's my unit circle. It's negative in quadrants 2 and 3, right? So negative, so it's going to be this way, this way. Okay. So what angle is that? Okay, so how big is that angle right there? Now, if you put that onto your calculator, cos theta is equals to negative root 3 over 2. And if we were to solve for theta, it would have gone like this. Cos inverse of negative root 3 over 2. Cos inverse of negative root of 3 divided by 2. And you're going to get 150 degrees. Well, that's because this is a 150 degrees. And then this, a reference angle of 30 degrees. So in quadrant 2, it's going to be 150. And in quadrant 3, it's going to be 180 plus 30. It's 210 degrees. Okay. Okay. Okay, letter C. We're going to do letter C at the back. Example 2, letter C. Tangent of theta is equals to 1, whereas tan of theta equals to 1. The tangent is a combination of sine divided by cos theta. So in this particular case, because it's equal to 1, that means the sine theta and the cos theta have to be equal to each other. So tan theta is equal to the sine theta over cos theta. For them to be equal to 1, then they have to be sine theta and cos theta have to be equal to each other. Well, where is the sine theta and cos theta equal to each other? Well, we could also ask ourselves, where is tan positive? Okay, so tan is positive in quadrants 1 and quadrant 3. So in that particular case, the x and the y are the same, creating an isosceles triangle over here. So this is going to be our angle right there. So it's going to be theta is equals to 45 degrees. That's in quadrant 1. And then another one in quadrant number 3. So it's going to be in quadrant number 3, that's going to be 180 plus the 45 degrees, which is 225 degrees. Okay. No, it's quite a lot. It's getting way too long. Let's do the final one. Example 3a. For each trigonometric ratio, state the measures of theta from negative 360 to positive 360. Now for this one, we're going to go theta has to be within negative 360 to positive 360 degrees. Okay, so letter A, secant theta equals to 2. Okay, let's go back to what does secant theta mean? Secant theta is a reciprocal of cosine. So if that's the case, the reciprocal of secant is cosine. So that's going to be cosine of theta is equals to the reciprocal of secant would be 1/2. So where is cosine of 1/2? Okay, where is cosine of 1/2? Cosine of 1/2 is going to be, cosine of 1/2 is, cosine is the x, so 1/2 along the x. Cos is positive in quadrant 1 and also in quadrant 4. So how big is this angle right there? That's going to be 60 degrees. So that's going to be 60 degrees, reference angle. We're going to need the reference angle to be 60 degrees in here. So in quadrant 1, it's going to be theta, it would be 60 degrees. In quadrant number 4 is going to be from here all the way to there. That's going to be 300 degrees. That's if it's a positive rotation. What if it's a negative rotation? So if we go this way, that's going to be a negative 60 degrees. And then if we go all the way around here, it's going to be a negative 300 degrees. So we have within this domain of negative 360 to positive 360, we have 4 solutions. Letter B, cotangent of theta equals to -1. Cotangent of -1. Well, cotangent is the reciprocal of tangent. So tan theta, reciprocal of that would be also -1. So where is tangent -1? Okay, I have to remember that tangent is the combination of sine divided by cos. And because it's a -1, tan is negative in quadrants 2 and 4. 2 and 4. And because it's -1, one has to be negative and one has to be a positive. Okay, so it's only, that's for theta r at 45 degrees. 45 degrees. So that's going to be 45 in here, 45 there. So in quadrant 2, it's going to be 180 minus 45 degrees. It's 135 degrees. In quadrant 4, it's going to be 360 minus 45 degrees, which is 315 degrees. Well, these are going to be for positive rotation. So rotating this way and then rotating this way. What about the negative rotation? Okay, so the other ones, if we do a negative, so it's going to be also negative 45 degrees. It's turning this way. And then the other one would be negative 180 and then another 45 degree negative turn. So it's going to be negative 225 degrees. So these are all 4 solutions. Okay. Last but not the least, sine theta is equal to 0. So where is the sine 0? Sine is 0. Remember, we have to remember that sine is the y. So it's 0 here and 0 there. So that means it's going to be theta is going to be at 0 degrees, 180 degrees, and then going all the way over here, 360 degrees. So those are all the positive rotations. If I go negative rotation, it's going to be negative 180 degrees. And then I have to go all the way around again, negative 360 degrees. In this case, there are 5 solutions in that one. Okay, wow. This is such a long lesson. There's so many things to unpack in here. Definitely lots of opportunity for you to try those questions from the book. Um, so memorizing the unit circle would be a great thing, but understanding it would be the excellent way. Like, I mean, everybody can memorize, but understanding is far superior than memorization. So in that particular case, I'm gonna leave that with you, and you have those questions on the book for you to try for yourself. Uh, so give those questions a try, um, and if there are any questions, please send me an email, and I will respond to you as soon as I can, and because I check my email quite a bit throughout the day. So please send me an email if there's a specific question that you want me to go over. I will go over them with you. Okay. So thank you very much for watching, and please stay in touch if you are having some questions. Okay. Have a great day, everybody, and take care. Okay, bye for now.